So here we're in chapter 5. We're going to talk about complex numbers. And what's the square? Let's start off real simple. Let's just start off really simple. Square root of 9. What's the square root of 9? 3. And what if a young child, I don't know, 8-year-old, 9-year-old, 10-year-old, asked you, why? Why is the square root of 9 3? What's the reason?
Because 3 times 3 is 9, right?
Because 3 times 3 is 9. That's the reason for square roots, huh? Yeah, because 3 times 3, because 3 times 3 is 9. So square root, in other words, asks the question, what times its very self will be this thing that's inside the root? That's what square roots ask, don't they? Which you already know. I just want to get you real clear because we're going to start doing some weird stuff with it now. So I want to get you super clear so when the weird comes, you're like, that's weird, but here's what I know. You know, and you'll be solid with what you know. So like, what's the square root of 25? 5. Yeah, and because 5 times its very self is 25. Good, we're super clear, right? Here comes the weird one. What would be the square root of negative 25? Is it negative? First off, is it negative 5? Would that be true?
No.
Yeah, you can't go to there, huh? Yeah. It's not a negative 5. That's not right, huh? Because negative 5 times negative 5 is not negative 25. It'd be positive. It wouldn't be negative. So that's not right. Right? Because we all agreed that square root, what we would tell that child, what Clarence would say to that child, is the truth. And that is, if a number times itself is the negative 25, then that's the answer. Well, there is no number times itself that's negative 25, is there? What number times itself is anything negative? How can a number ever be multiplied by itself and come out negative? It can't. Is that making sense to you? I'm not seeing furious like, yeah, but you don't have to be that way. But I just want to make sure that's happening in your mind at least. Is that making good sense?
Yes.
Right? How could we ever have a number times its very self come out negative? No. I'll say no, that's not going to happen. Now if you have a negative number times itself, that'll be positive. Now you might say, well, okay, Mr. Aaron, just have one negative and one positive. That'll be negative 25. Well, yeah, that's true, that's negative 25, but that's not a number times itself. That's a number times its opposite. That's not allowed. We all agreed. Clarence said it, and it's true. It's got to be the number times its very self, not times its opposite. So anyway, so with all that said and thought about, what's the square root of negative 25? You can't do it, can you? You cannot. There is no real life number times itself that's negative 25 or anything negative. No way to do it. But we'd like to do it anyway. There's no real way to do it. But we'd like to do it anyway. So what do?
Could you do the
Make up numbers.
We use our imagination. And we say it's 5 imaginary units. Is that true? Am I just like joking around up here? No, that's the truth. And that's exactly the truth. And I stands for imaginary. It's not real. Right? That's the answer. Notice we say, well, okay, the square root of 25 is 5, but the negative's there, so it's not real, so it's 5i. We imagine it would be 5 if you could do it. That's what we're saying. Isn't that weird? I mean, what are we even doing here? I mean, come on. Why do they make you take this stuff?
How do we apply this in real life?
Yeah, right. I mean, we're using our imagination now? Was that in the curriculum for this class?
Well, math is made up.
Ah, yeah. What have I been saying? Because if you're looking at that going, come on, you're telling me that's imaginary? We're just using our imagination? Yep. But I would say back to you exactly what Pauline just said. This isn't the first time. We didn't just start making this up. We've been making it up the whole way, remember? All of math is made up, not just the imaginary units. It's all made up, right? It's not real. You can't see 5. If you swear that you can see 5, they're have you ready for the rubber room, right? You can't taste, touch, or smell math. It's all made up. Even the imaginary, it's all made up. Why? Because I needed a job. They had to, no, it's not that. I wasn't taken, I know some people think there's like a conspiracy. I was taken into the trust while just a baby to foister math on the rest of the world. No. No, it's why do they make up all of math? Because it's useful in the real world. Now, would you believe that 5i is useful in the real world? Well, let's keep going, and then we'll ask Google in a little bit. I'll do a Google search today. So, 5i is an imaginary unit. That's really right. I'm not kidding. I know it's hard to tell when I'm kidding and when I'm... That's completely serious. That is the answer. So when you have a negative in a root, it's not real. There is no real life number times itself that's negative 25 or negative anything. So what you do is you just do the root. Root 25 is 5, and then you just throw the I out there for imaginary. So negative inside of a root comes out as I. That's the moral of the story. That you already know, I hope, from intermediate algebra. You remember that? Sort of? Are you fresh off intermediate algebra? No? All right, so negative inside of a root comes out as I. Comes out as I. All right, so this won't be hard. It's weird, but it's not hard. So like, what's the square root of negative 36, for example?
6i.
Yeah, because the square root of 36 is just 6, and negative in a root comes out as I, 6i. So it's not hard. It's just weird, right? Got a negative in there. Can't do it. It's not real. Like Jose said, your calculator will just tell you error. You just take the negative out, it becomes an I. So negative in a root comes out as I because it's not real. There is no real number times itself that's negative 36. So you just say, if there was, I would imagine 6 imaginary units. Okay, so now what we want to do is we want to take these imaginary numbers. We get some imaginary numbers now. They're not real. And we want to put them together with real numbers. So we want to say, hey, okay, what if we take like 7, that's a real number, plus 6i? Kind of like put them together. Now that doesn't make 13i. If it was 7i and 6i, that would be 13i. But that number will just stay as it is. You can't simplify it any further. But that together, those two parts together, are one number, which we call. Does anybody know what we call it when you have a number that has a real part? 7's real. I can have 7 coins in my pocket, right? 6i is not real. I could not have 6i coins in my pocket. That's impossible. So this is one number. Even though it's got 2 numbers in it, it's one number. It's got a real part and an imaginary part put together into one weird combination. And what do we call a number that has 2 parts to it?
Complex.
That's a complex number. That's the name of this section. That's what this section is all about. Complex numbers. What's a complex number? It's a number that has a real part and an imaginary part. It's complex. It's got both things. Real part and imaginary part. All right. Now we're ready for Google. Are you ready for Google? So complex numbers, real and imaginary. Let's ask. Google knows everything. We all know that, right? Google. Let's go to Google. And we'll say, all right, Google, real life applications of there, see, it pops up. This has been searched once or twice before. Real life applications of complex numbers. What are complex numbers used in real life? What is not, while it's not a real number, imaginary numbers, real life applications such as electricity as well as quadratic equations. I don't know if you call quadratic equations real life, but electricity is real life. What are some jobs? Here we go. What are some jobs that use imaginary numbers? Many careers that employ higher mathematics, complex numbers. Electrical engineers, that's true. We'll even have one problem at the end of the section that's an engineering problem. They use it for current. The current that comes out of the wall, the alternating current, has basically where you use it, you might think, well, what is it, imaginary? Is there imaginary stuff coming out of the wall? No. You just, remember, all of math is made up, not just the imaginary numbers. So you just use that to represent things that are real. So anything in life that has 2 components to it that are separate but still kind of interact, perfect thing to represent that is complex numbers. So the alternating current that comes out of the wall has both, the current has both voltage, volts, and amperage. Has both those characteristics to it. So they use complex numbers to represent the current that comes out of the wall, because it has the two components. And they let the I part be the current, and the real part be the voltage. They put those together. I actually did some of that. I was engineering for a while at Cal Poly before I changed to math. So anyway, enough said. I'll let you do more searching. I'm not here to do a Google search class. But there we go. So let's learn complex numbers. What I mean is, we went into we just finished coming out of the whole new world of vectors. That was all brand new. And now we're in the whole new world of complex numbers, which are going to be super similar to vectors, actually. Very, very similar. These are what this class does, what trigonometry does, is lay a lot of foundation for other classes, pre-calc and calc, where you'll use these things. So that's why we keep jumping kind of from world to world. So we jumped into the vector world, and we did just the basics of vectors. And now we're jumping out of that into the complex number world. That's what whole chapter 5 is about. Complex numbers, and we'll do just the basics with complex numbers. If you go higher math, pre-calc, calc, and even beyond that, there's whole classes on these things, entire classes on complex numbers and what they do. And my son just last semester, finishing his math degree at Fresno State, just last semester he took complex analysis. He did a whole class on complex numbers. It's the whole thing's about. Yeah, it's just more and more stuff. Yeah.
Illegal in the math world to use I as a variable in any other context? Like, why is it that in vectors I means one thing, and then but I is definitely the only variable for imaginary numbers. So if it's used in other contexts, though, it makes me so mad.
Right, it would be better if they kind of reserved I to only be for the imaginary numbers, right? Yeah, and it's going to get worse than that, Bernadette. Let me answer your question by saying you're totally right, and they're going to make it even worse than that. Not only are they going to start using I in places where they don't mean I, the imaginary unit, but remember what I was in the vector section?
Yeah.
I was what? Sideways, right?
Yeah.
I was sideways, J was up. In about half an hour, maybe 40 minutes, we're going to take these complex numbers, and we're going to look. This is going to be all about complex numbers, how you add them, subtract them, multiply them, divide them, and then we're going to put them on graphs. When we put them on graphs, the I, which for vectors was sideways, is going to become up and down. It's actually going to switch the direction on us. Yeah, and then a week from tomorrow, you'll have a final with all that stuff, and you got to keep all that straight.
And how are you going to tell them apart?
They do this on purpose.
And whether it's a vector or a complex number, that'll be the sign. Yeah. All right. So we're in this whole new world, complex numbers. We want to learn how things operate in this world. And so we've made up, and they made this up, this thing called complex numbers, because real life things with two components, it's helpful. So we have to make up the rules for how you add, subtract, multiply, and divide these new creations called complex numbers. All right. It's really actually pretty easy. This 5.1 will be a very easy section. How do you add complex numbers? What would you do if you had to make it up? How would you add two complex numbers?
Add and subtract like terms.
Like terms, exactly. Just like terms. It's just totally natural. Just like terms. So I'll just go 9 plus 7, 16. And then minus 7i plus 4i minus 3i done. Just real with real, imaginary with imaginary. We good? That's all there is to it. All right, can you do that? Just remember negatives in a parenthesis, distribute through the parenthesis, and just gather like terms and all that, and you'll be fine. So that minus will go boom, boom, and this minus will go boom, boom. So we'll get 8 plus 1 minus 4i plus 8 plus I. Good. And then that's 8 and 1 and 8. What's that? 17. Minus 4i. Minus 4i and plus 1i is minus 3i, and done. Is that good? That answer is that is a complex number with two parts. Real and imaginary. It's complex. Good to there? All right, next problem. So we just added and subtracted complex numbers. Now we want to multiply them. We're moving along rather quickly. Add, subtract, now we're on to multiply. So how do you multiply two complex numbers? You know, just distribute, right? It's very natural. So just take that 7i, go boom and boom. Like that. We're going to multiply two complex numbers. So 7i times 9. 63i. Minus 7i times 8i. 7 times 8? 56. And I times I?
I squared.
I squared. Good so far? So I'm just multiplying, just treating that I like any other letter. Right? Now we got to pause for a second. What's I squared? We got I squared up there.
It's the square root of -1 times the square root of -1, which means it's -1.
How'd you know I was the square root of -1?
Because it's an imaginary number.
It's an imaginary. How'd you know it was that particular number? How'd you know it wasn't the square root of -7?
Because the square root of 1 is 1.
Right. Yeah, you're right. Everything you just said is true. Very good. Yeah, think about first. We have to figure out what I squared is. Bernadette just told us it is -1, plain -1. Let's see why that's the truth. Remember the square roots we were doing a minute ago, right? What again was the square root of -9? How do you do that again? Let's just remember. Square root of -9 is 3i, because you do the square root of the 9, and then the negative inside the root comes out as an I, huh? So it's 3i. What's the square root of -4? 2i, right? Because the negative inside the root comes out as 9, square root of 4 is 2. Good? So then what's the square root of -1? 1i, because the negative comes out as an I, and the square root of 1 is just 1. 1i or just I.
It's just an invisible 1.
Good so far. So we have found what I itself is. I itself, 1 times I, is square root of -1, like Bernadette said. That's true, isn't it? I is the root of -1. We agree? First off, because the square root of 1 is just 1, and negative inside the root comes out as an I. So what is I? So this I right here is the square root of -1. Now I'm just going to leave that. I don't want to write square root of -1. I mean, that's imaginary. You can't do the square root of -1. So I don't want to write that. I'm just going to leave it I. Good enough. But I squared. That's the square root of -1 squared. Right? Because we agreed that I was the root of -1. So I squared is the root of -1 squared. What happens when you have a square root and a square? They cancel. Don't they? Right? Like you know that. They're opposites. So it's just -1. So I squared, therefore, is just -1. Plain, real life, -1. Do you guys get that? Did you catch the significance of that? Don't let those just be symbols I'm moving around on a board for you. I'm not on a board, but on the overhead thing here. Right? I've been teaching 20 years on the board, so it just comes naturally out of my mouth. Did everybody see that? I squared's a real life number. I itself is imaginary. They're very different. I could have, not in my pocket, but in Minnesota in February, the temperature outside, or the temperature in your freezer at home right now, could be I squared. -1. That's possible. That's a real life number. My bank account has been there and worse, right? I've lived there. Yeah, my wife and I were just talking about that 2 nights ago. We have 3rd kid in college in the fall, and my bank account is suffering. We make a deal with our kids. We pay 2 years at Fresno State. That's it. You want to go somewhere else? Like my Emma girl wants to go to Cal Poly. She's at Cal Poly. Well, she's home. Anyway, she's at Cal Poly, and then you pay the rest, sweetie. If you want to enjoy that beach, then you're going to the tune of $15,000 a year of debt. We're real clear with her. That's going to be your baby. Anyway, so even just that, though, 2 years at Fresno State for, our third child now is killing us. Yeah. So your bank account can be I squared or worse. That's a real life number. I squared is -1. Right? So that's a real life number. Whereas your bank account could never be I. The temperature can never be I. Root of -1. That's imaginary. You can't. That's not real. So everybody's seeing the point. Therefore, we're always going to leave I. Because I is not real. You can't do anything with that. But I squared, we're not going to leave I squared. That's a real life number. I'm going to say, hey, don't leave I squared. That's just what? That's just -1. Plain, normal, regular -1. So whenever we see I squared, we always replace I squared with -1. Because it's a real life, plain, normal number. So don't leave it I squared. Replace it with -1. So, okay. So what does this problem become then? 63I minus 56. But in the place of I squared, I'm going to put -1, huh? Everybody see what I did there? You never leave I squared. You leave I, because that's just imaginary weird. But I squared you never leave, because that's a real life -1. So just put it in there, and then so what does this become? 63I negative 56 times -1 plus 56. We're done. That's the answer. So in effect, I squared just ends up changing the sign of whoever he's next to, because he's -1. Is that okay if I just skip that step from now on? I'll go from 63I minus 56I squared to plus 56. Because that I squared to -1 just changes the sign of whomever he's next to. Does everybody see that? So I squared is just -1. We never leave I squared. It's a plain, normal -1. All right. 2 minus 6I, 3 minus 5A. So now we're going to multiply. You know how to do this, right? It's just pretty much normal FOIL. But whenever I squared shows up, replace it with -1. All right, so try that. So go ahead and FOIL. First to both, second to both. You know how to do that kind of thing. Multiply. We're multiplying now two complex numbers. So here we go. So that 2 is going to go to both. 6 minus 10I. Good there. And then that minus 6I is going to go to both. Minus 8I plus 30I squared. Good to there. Good so far. Just normal FOIL. Now, these two in the middle are like terms, aren't they? Minus 10, minus 18, minus 28I. And then what do we do with that 30 plus 30I squared? The I squared is -1, so that ends up becoming minus 30. We good there? You just change the sign of whatever's next to I squared, because I squared is -1. So then 6 and minus 30 can now combine, because now those are both just regular real life numbers. 6 take away 30? Minus 24, minus 28I, done. Is that good? That's a complex number. It's got a real part and an imaginary part. We just multiplied two complex numbers and got a complex number answer. Are we happy about this? Guys able to crank along in your own homework? Working out okay? Okay, right? Well, it's a 2. I guess it's a real number divided by a complex. So we're dividing a real number 2 by a complex 9 minus I. How do we divide? Now we've added, subtracted, multiplied. Now we're dividing by a complex number.
Is this similar to when we have roots in the bottom of the...
Beautiful, Pauline. Exactly the thought we should think. Yeah, what's an I? Remember, it's a root. It's a root of -1. Exactly what you should think. When you look up at that, what you should think that'll be really helpful to you is if you think, look, that I, that's like a root. It's a root. You don't have to write root of -1 and be all specific. I'm not going to really do it that way. But I just mean that's how you should think. You should think that's a root. And what do we do when we have roots in the bottom of a fraction? Yeah, well, it depends two ways. It depends whether they're glued on the bottom or not glued. Do you remember? Let me remind you real quick. What if you had like 2 over 9i or 2 over 9 minus I? Those would be handled very differently. Do you remember? Because this one's glued. This one down here is glued. Remember, plus and minuses glue things together. Costco, package deal, that whole thing. It's a big deal in algebra. So on this one, those guys are glued. And so I could not just multiply by I. You can't separate that I. That's what I would do up here, by the way. I would multiply just by the I because the I is the root. Am I confusing you here? Let me make it a root. I'm probably confusing you with the I. What if this was like a root of 3 and this was like a root of 3? Okay, what would you do up here on the top one? You would just multiply by root 3, right? You wouldn't care about the 9 or anything. Right? Just whatever, who cares? Just multiply top and bottom by root 3. You'd get 2 root 3. And what's root 3 root 3? Plain 3 times 9, 27. Done. Got rid of the root from the bottom, right? We've done those before. Remember that? That's because the 9 and the root 3 are not glued. They're not a package deal. They're not shopping at Costco. They're just shopping at the local supermarket where you can buy just one. So we just do the root 3. But down here, I cannot do just the root 3. That won't work. These guys are glued. They say, no. You buy all of us or none of us. We're a package deal. So what do you have to do in that case? Do you remember? The conjugate. You got to do the opposite sign in the middle. Remember that whole thing we learned about the opposite sign in the middle? And FOIL and all that. I won't do it all. So I'm just reminding you of roots because that's what an I is. Remember, an I is a root. It's a special weird root, but nevertheless it's a root. So when you look at 2 over 9 minus I, you want to think, oh, that's like 2 over 9 minus root 3. It's exactly what it's like. And so, Pauline, what should we do in this case then?
Multiply both top and bottom by the conjugate.
Exactly. By 9 plus I. Exactly. Did y'all see it's the same thing? I'm trying my best to tie it to something you already know so you don't have another new thing to remember. It's the same thing we've already done. It's just a root. An I, just keep in mind, an I is just a root. So do whatever you would do with roots. And if you had a root added or subtracted, package deal, conjugate. So it'll kind of reinforce that old stuff and also help you with the new stuff. So it's a win-win if I can get you to remember something old and show you this is the same thing. It helps the old and makes the new easier also. So we're just going to multiply the top and multiply the bottom. Just crank it out from there. So let's do that. Here we go. So I'm going to take that 2 and go boom, boom. That'd be 18 plus 2i. Everybody get on the top so far? The 2 just distributes. On the bottom, it's a big FOIL. So we're going to FOIL out that bottom. That 9 goes to both. 81 plus 9i, boom, boom. Minus 9i, minus I squared. And then plus 9i minus 9i. Like that. Those drop out, right? Now what's the bottom going to be? Am I going too fast? Is this making sense? Everybody okay with how I foiled out the bottom? Do you see why we do conjugate, which means opposite sign? See, if this had been 9 plus I on the bottom, then I would have multiplied top and bottom by 9 minus I, wouldn't I? You always do the opposite sign. Why? Because then you get this to happen. See how the plus 9i and the minus 9i drop out? That's what you want to have. You want to get rid of those i's from the bottom because they're roots. We don't want any roots on the bottom. We don't want any i's on the bottom. And the other I squared is going to drop out too because we never leave I squared. That's just negative 1. So minus I squared is going to actually become minus minus 1, isn't it? It's going to be 81 minus minus 1, which you know is plus 1, so that's just 82 on the bottom, isn't it? Everybody good there? See how that got rid of all the i's, the roots from the bottom? So now, are we done? Very close, almost. Last thing is the format in which they want the answers. They want the answers in the A plus BI format, meaning they want you to separate the real part and the imaginary part. The complex number has both those parts. They want them separate. So that means right now I have 18 plus 2i over 82, right? 18 plus 2i over 82. I can't leave it that way. Type it in that way, it'll give you the although message. Have you got the although message before? Although your answer's right, we ain't giving it to you. No, they don't quite say it like that, but that's really it. Although it's equivalent to the real answer, we don't like the format. They want it separate. So they want you to say 18 over 82 plus 2i over 82.
Will they want it simplified though?
And then simplify those fractions, yeah. So I'm going to reduce both fractions.
So what if it doesn't simplify them? Can't you just do
If it doesn't, you just leave it.
into this form right here? It still
Yeah.
has to be in that form.
It has to be separated.
Oh.
Yeah, you have. That's what they're
It
saying
has
here
to
when
have
they
two
say
separate-
A plus BI.
Two
That
separate
means
fractions.
two things separate. Yeah. So then divide top and bottom by 2. Be 9 41sts plus 1 42nd I. Say I divided by 2 here. And you could put that I over 42. That I can go in the front or the top. Is everybody good to there? Is that making sense? That's the way they'll take it. Why do I say it's okay? You can either put the I in the front or the top. Are you guys aware of that rule? That could be an X for all I care. It's the same rule. Why is it true that you could have, say, an X in the front or in the top? It's the same thing. Do you know that from algebra already? Why is it the same to put anything, X or whatever, in the front? That's the same as the top. Why is the front the same as the top? Because the front is really
X over 1.
over 1. It's really in the top, isn't it? You with me on that? So whether there's I out front or X out front or anything out front, to be out front is the same as to be in the top because you're over 1. You are in the top. Right? So that's why I say that. I don't want you to get thrown off on the multiple choice test. I really don't. I don't know if you feel like I'm trying to fool you. I'm really not. Publishers write those questions anyway. I'm just trying to help you with them. So if on the multiple choice test we take next, Wednesday, they change those forms. No, those are the same. Grab that answer. Those are the same thing. To be in the front is to be in the top. Because if you're in the front, you're over 1. You're really in the top. Good there? We're done? There's the answer. Is that making sense? What did we do? We divided by a complex number and turned it into a complex number answer. But you never want I in the bottom in the end. Because that's a root. We can't have roots in the bottom. Good? Want to try one of those? All right, so try that one. 8i over 4 minus 3i. So you know what to do. You got roots in the bottom. When you look at that on the exam next week from today, you should look and say, oh, that's a root down there. That's a root. I can't have roots in the bottom. Right? Can't have roots in the bottom. Can't have i's in the bottom. So they're glued together. Got a minus down there. It's glue. It's Costco glue. Right. Can't have that. You got that, so then package deal. Multiply top and bottom by the conjugate. 4 plus 3i. Top and bottom.
problem, maybe, just like rows, really, like multiply the rows of the denominator, and then negative 1, if it's not the integer 7.
Right, because that was I squared and just regular on the top.
Sure. Okay, so we're doing the eyes.
Yeah, we leave the i's, but the
Okay.
I squareds we replace.
Okay.
Yeah, correct. Okay, so I'm going to multiply top and bottom by 4 plus 3i, the conjugate. Right? We good there? The conjugate. All right, so take that 8i, go boom, boom. 32i plus 24i squared. And I'm not going to leave that I squared. See how I squared shows up? Remember, I leave regular i's, but I do not leave I squared. I replace I squared. So on the bottom, let's finish the bottom first. That'd be 16 plus 12i, and boom, and a boom. Minus 12i minus 9i squared. Get to there? So far, so good. Now on the bottom, we're going to cancel these out, aren't we? Plus 12i minus 12i, they cancel out. That's why we did the opposite sign, so that would happen. That was intentional because we wanted that to happen. That's why we do the conjugate, opposite sign, so that'll happen. And so now I'm going to replace two things. Everybody clear on this? I know this is a confusing point. Let me say it again. Plain I we leave, I squared we replace. So this guy and this guy, those two, that's going to be -1 and -1, whereas that guy stays I. Huh. Regular i's, we just leave those because they're weird. They're root of -1. They're weird. I'm not going to do anything with those. But I squared, that's just plain old -1. You could have an I squared temperature in your freezer or bank account, I squared, right? That's a real life -1. So we don't leave that I squared. So what do we got then? We have got 32i minus 24 over 16. Minus 9i squared will become plus 9. That bottom is therefore 25, isn't it? Right, we good there? Everybody see what happens? That minus 9i squared became plus 9 because I squared is -1. Changes the sign of whatever it's next to. So then we got to separate them. 32i over 25 minus 24 over 25. There we go. We're done. How we doing? Any questions? Is that good? All right, you guys are awful quiet today. I hope that means it's all sinking in good. Let me know if there's anything you want to talk about. Practice on going back to the roots. Can you simplify that? I think that would be super easy for you. What's the square root of -36?
6i.
6i, right? Negative in a root comes out as I. So the negative in here comes out as I. And the negative in here comes right to the front of the root as I. Negatives in a root come right to the front of the root as I. So what do we get here? 6i minus 4i. Oh, 2i. Oh, forgot to screw with the 4. 6i minus 4i. We get so far? And then that's just 4i, isn't it? 6i minus 2i? 4i done. Just like terms. This one of your favorite sections so far? Not too bad. We're laying the foundation, and then we're going to do crazy stuff with it a little bit at the end of today, especially tomorrow. That's how it always works, right? We enter a new area, get the kind of the verbiage down, and then they do stuff with it. So good to there? All right. Okay, so try that one. I would do that square root of negative 100 first. What is the square root of negative 100? 10i. So everybody good? Square root of 100 is 10. Negative in a root comes out as I. So I would right away say, hey, look, this is negative 10 plus 10i squared, isn't it? Everybody good with that? First off, the square root of negative 100 is 10i, because negative in a root comes out as I. And then the square root of 100 is 10. So take that. Now, what do you do when you have parenthesis with a 2 power? Well, you got to write 2 parentheses. Right? You with me on that? You've got to actually write 2 parentheses and FOIL.
What if the root being canceled by the 2?
Yeah. Okay, yeah, good question. Let me mention this. Could I do this? Could I take that 2 and go boom, boom like that? Negative 10 squared is 100. 10 squared is 100. I squared. Just do that. No, that's technically illegal. And Jose, I know you were meaning over here.
Yeah.
Can't I just square that and then square that root and get rid of that root? Both of those, both this and what I just did there, are illegal. You cannot take that 2 from the outside and go to both of these. You can't do it here either. Instead, you have to write minus 10 plus 10i minus 10 plus 10i twice, and then like the FOIL stuff. You have to do it that way. Why?
Because it's squaring the...
Because of the plus sign. What causes all of the problems in algebra? If that was not a plus sign in the middle there, if that was times, I could totally just square it, no problem at all. Like always. See how that Costco thing is coming up all the time? So you want to recognize when things are added and subtracted, you have to do it the hard way. You have to do it the long way. No shortcuts ever are allowed. They're not true. Does that make sense? Now, I can prove it to you, and you might think, why? Why do they make such weird rules? It's just what's true. It's just what's true. Let me show you with numbers. I don't know. I don't want that to seem like some weird thing. Just think about numbers. What if you had 3 plus 4, and you had a square on it? Does that really equal 3 squared plus 4 squared? Is it true to just, in fact, let me make it easier. How about if it was just 2 plus 3? I want to make it easier numbers. How about if it was just 2 plus 3? Is it right to just square the 2 and square the 3? Well, this would be 4 plus 9. It'd be 13. Is this 13?
No, it's 25.
No, it's 5 squared, isn't it? Jose, you good with that? Isn't this 5? 3 plus 2 is 5. 5 squared is 25. It's not 13. See how it's just not true? It's just not true to take a power and go like that. It would come 2 squared plus 3 squared, which would be 4 plus 9. That'd be 13. This is not 13. It's 25.
So that would fall under like the order of operation, right? The parentheses first before the exponents?
Not totally. Kinda. I know what you mean. I know. Yes, sort of. Yes. I know I'm answering like a politician here, huh? Yes. Well, as long as you vote for me, yes. What it is, because the reason I hesitate, Jose, and everybody, is because, you know what, if it was times in there, if it was 2 times 3, you actually could do it then. But you could still do what you're saying, Jose, about the order of operations. Make it 6 first, and then square it, which is 36. But notice you're also allowed the freedom of just squaring this one and squaring this one. See how it'll actually be true? What is 2 squared now? 4. What is 3 squared? 9. See, it's the same. It's still 36. See how with times it's okay. With adding, it's just not true. So, with all that said, we have to remember that when things are added and subtracted, we have to do them the long way. The short ways will never work with adding, subtracting. All right, so that's a bunch of scribbling, but important questions to get straight on. that when we have plus and minus Costco glue in the middle, what do we have to do? We have to write two of them. I have to write minus 10 plus 10i minus 10 plus 10i. Write two of them and foil. Foil it on through. So here we go. Boom, boom. So we'll get 100 minus 100i. He's done. Boom, boom. Minus 100i plus 100i squared. Good so far? So I just foiled on through there. First to both, second to both. Now, can we combine like terms? The middle, that's minus 200i. Now, what do we do with that 100i squared? Yeah, what's I squared? Negative 1. So that'll become minus 100, won't it? You with me? Remember, I squared, we never leave I squared. We leave plain I. We leave plain I, but we never leave I squared because that's a real life negative 1. Negative 1 times 100 is negative 100. Huh. And then these cancel. What's the answer? Negative. That negative is still on the 200. Negative 200i. How are we doing? Is that good? You getting down all these complex number rules? Remembering your root rules from high school? Or whenever you took algebra?
My original question was, why doesn't the exponent in the beginning cancel the root, like we normally been doing?
Jose, I thought I was so clear on all that. No, I know it's confusing. It's because he can't go in at all. Because of that plus, that 2 cannot go in and hit that root in any way, shape, or form. Because of that plus sign. That's what I was saying with all those examples. He's not allowed to go in. But yeah, if he was allowed to go in, he would do just what you're saying. But he's simply not allowed to go in. It's just not true because of the plus. Is that making sense to everybody? Is that good? With that plus in there, no, not allowed. You have to write 2 parentheses instead. That's the only way it's true. That 2 can't go in. Good on this one? Any other questions I can answer on that one? Those are good questions. We're learning a lot of those little algebra rules, what you need for if you're going to go up the line to pre-calculus. All right, onward and upward. How do you simplify the square root of negative 18? Negative inner root, what does that do? Comes out as an I. So that negative in here will come out and be an I right there in front of the root. It doesn't go anywhere else, just goes right in front of the root.
Would it be wrong if it was after it? Like
Oh, you can put it in the back. That's okay.
Oh, okay.
Like, you mean like back here like this?
Yeah.
Yeah, that's totally fine as long as it's not The only reason people don't usually do it, well, some is because it might be a little confusion as whether it's still under the root or not.
Oh, okay.
But it's fine. It's totally fine. Either way, as long as it's clear it's out of the root.
Okay.
Yeah. So the negative in sends an I out, one way or the other, front or back, out of the root. And then how do we square root the 18? Remember that? What's the square root of 18? Remember from your algebra days? I'm always saying that, huh? Your algebra days?
3 root 2.
Yeah, because 18 is 2 times 9. Square root of 9 is 3. So it's 3 root 2, isn't it? So this thing becomes negative 12 plus 3 root 2. Yeah, I like Ani's idea. Let's just put the I at the back. Not 16. I'm changing the problem. There we go. I'll just put the I at the back. You can put it in the front. Doesn't matter. Good so far? I just simplified down root 18, 3 root 2. The negative in the root came out as an I. Now we can't give the answer that way. We have to separate it because they want the 2, the A. They want the A plus BI. They want them separate right here. So we say, okay, minus 12 sixtieths plus 3 root 2 sixtieths. If you have the I in the top, that's fine. Remember, it's the same thing. Front, top, same thing. Doesn't matter. Now I can reduce those fractions, huh? 12 goes into 65 times. 3 goes into 60 20 times. So I end up with minus 1/5 plus root 2 over 20 I. Done.
Wait, so you can reduce the 3 and the 60, even if it's in front of it's not like a package deal or?
Yeah, they're not glued, are they? There's no plus or minus between them, huh?
Oh, okay,
Yeah, that's exactly the issue. It's not glue.
okay.
You're shopping at Save Mart there. You can buy just one. Yeah, if there was a plus there or minus, then I couldn't do that. Good question, good clarification. Yeah, that's why I'm allowed to do the 3 into the 60. We good there? Is that making sense? Questions on that one? All right, and hey, here's a mistake I see a lot. I'll see people do all this good work, and they'll go minus 5. Why is that not minus 5? This.
Because you're dividing by.
The 5's in the bottom, huh? See, the 60 was in the bottom. The bigger number, 12 goes into 60. The bigger number's in the bottom. So it's not minus 5, it's minus 1/5, right? I see that mistake a lot. The bigger number's on the bottom. So the leftover 5 is on the bottom. The 12 went into the 60, not vice versa.
You're dividing both top and bottom by.
That's another way to say it. Yeah, you're dividing both top and bottom by 12, which leaves 1 over 5, doesn't it? Yeah, good. Okay. So I would first let that negative come out of the roots as i's, and I would clean up that root 18 before I multiply. It makes life easier to clean it up right now. Remember what 18 is? Simplify that root 18, let the negatives in the roots come out, and simplify the roots. So the negative comes out as an I. And then what's the square root of 18? 2 times 9, 3 root 2. So that'll be negative 3 root 2I times I root 5.
Why, as I say, why is it a negative?
Thank you. It's not negative, and I'm messing up. It's a good teaching point, though. Yeah, that's why I did it. Yeah. Negatives in a root don't come out negative, do they? I messed that up. They come out as an I.
What about the negative?
Did I mess up again?
5? Isn't it 5i?
Okay, so the negative in the root comes out as I.
The second one. It's like
I know.
Right.
And the negative in the root comes out as I, but the 5 has to stay in.
You can't root the 5.
Because you can't root 5.
Oh, okay.
That makes sense?
Yeah.
Whereas the root 18, we simplified. But you can't simplify root 5.
Okay.
So just the negative comes out as I, but the 5 stays in.
Okay.
Everybody good to there? Is that making sense? So yeah, watch out. It's easy a mistake to make what I just did, where you take that negative on the inside and you pull the negative out. It doesn't come out negative, it comes out as I. Okay. Now, now let's multiply this on through. Now, you remember how to multiply root things?
Here's one.
What's that? Yeah, the outside numbers multiply outside numbers, inside numbers multiply inside numbers, right?
Right.
When you multiply roots.
Oh, so the i's on the outside.
Yeah, eyes are on the outside.
Okay.
You good there?
So that's squared.
All is well? When you multiply, they're outsiders with outsiders, insiders with insiders. I told you my father-in-law, football, Sac State, playing the jail thing, right? Outsiders, right? So remember that analogy? Outsiders, when they went to play football, so if you're an outsider, you're an outsider. If you're in the jail, you're in the jail, right? When my father-in-law was coming out of the stamp and all that. So remember that. Outsiders with outsiders, it's a big deal. If you go to visit a prison, it's a big deal whether you're an outsider or an insider. You get to go home or not, right? So an outsiders with outsiders, insiders with insiders. So as this multiplication happens here, who are the outsiders? The 3, the I. They're outsiders. They're not in a root. They're not in. So 3 times I, 3I squared, and the insiders, 2 times 5, 10, minus. Good so far? Outsiders multiply outsiders, insiders multiply insiders. The next one, just getting almost too many marks here. Next, I'm going to have 3 root 2I multiply root 3. It's going to be 3 root 6I. Everybody see that? So this guy went boom, boom. Everybody see what happened there? Outsiders with outsiders, insiders with insiders. Can we do any more?
Yes.
I squared we never leave, because that's a plain number. A plain i's we leave. I squared we never leave, that's -1. So that's going to be -3 root 10, right? That I squared becomes -1 minus 3 root 6I, done. So we never leave I squared. Plain I we leave. Done. Yeah.
Like, looking at it now, I know it wouldn't make sense, but like, I'm just like remembering from the last problem, you said how the -3 in front isn't a package deal with the root 10.
Where are we at?
Final answer. Like, the
Yeah.
-3 isn't, so like, I know you can't do it, but like, wouldn't it make sense to do -3 minus 3?
Those are unlike terms.
Hmm?
Those are unlike terms. You wanted to subtract these?
Yeah.
No, these are unlike terms. Remember from algebra? So from algebra, if you have -3 root 7 minus 2 root 7, you could subtract those because they have the same roots.
So it is a package deal then?
This isn't about packages or not about packages. This is about like terms or not like terms.
Okay.
So these are both root 7s, so we could do it. These are different roots. So this is like different letters. Is that making sense? This is like -3x minus 3y. They're just like different roots, different letters. On that. Packaging is when you have plus or minus between two things.
Yeah.
Making sense for you, Ani? So like if you had 3 plus root 2, those are glued together. So I don't, yeah. So that's a different kind of situation. That's for canceling or not canceling on that. Yeah, we have this answer. I hope I'm answering your question. I'm not sure if this is what you meant. But yeah, we can't do any more here
Yeah.
because those are unlike terms is really the deal. This is like an X and a Y. Different roots are like different letters.
Yeah, it doesn't even look like it should be like even more simplified. I was just wondering.
Yeah, just like that. We good? Other questions on that one? Okay. So yeah, we got to do a couple of foils. I'm going to give that a try. And then gather everything up. So this one's tricky. Make sure you give this one a try. I don't know if you're moving ahead in homework or where you're up, and I encourage you to stop and give this one a try. This one has got a trap that gets probably more than half the people that try it. So it's really an important one to try. Give this a try, and then I'll jump in and finish it up. So I'm going to FOIL these first two. So boom, boom. We get 12 minus 3i, boom, boom, minus 16i plus 4i squared. Good so far? I FOILed the first two. I'm going to gather like terms and stuff. Watch all your signs really carefully. Now, here's the real part that gets everybody. Do you see this minus sign right in the middle? That's going to need to distribute through whatever answer, all the parts of the answer that we get from the FOIL in the back of it. Super easy mistake people make there. Let me show you. So this is going to become, if you FOIL this right here, you'll get 9 plus 3i minus 3i minus I squared. And then these cancel, so you get 9 minus I squared, but it's all got a negative in front of it, huh? So really what it is, it's like this. It's minus the whole quantity, 9 minus I squared. Is that making any sense?
So we wouldn't distribute the negative before we started factoring?
Yeah, it's just too there's a way to do that correctly, but it's confusing. I'd rather not go there with you. You basically would put it through one of these and not the other one, which is probably confusing. And it's easier to just say there's a minus in front of the whole group. That'd be easier way to deal with it. So yeah, there's a minus in front of the whole group. If you FOIL this out, you get 9 minus, and you gather, and you let the terms in the middle cancel. Then you get 9 minus I squared. But it's minus the whole group. So it ends up being minus 9 and plus I squared. That's the mistake. People forget about that plus I squared at the back. They have it wrong. They have minus I squared. Because they didn't realize that minus needs to distribute to the whole answer. How are we doing? You doing good? Always about this time I'm wondering if you can make it to the break. Are you okay? Hour and 15 minutes of talking math at you. All right, so this part now is going to become 12. Now the middle two are like terms. Minus 3i minus 16i is minus 19i plus, and what do you do with 4i squared?
Negative, or minus 4.
Yeah, remember we never leave I squared. I squared is negative 1. So that's minus 4. And then it's going to be minus 9 plus I squared.
No. Minus 4.
In a minute. Yeah. We good to there so far? There's a lot of little signs here. There's a lot of chances to miss a sign. Everybody good. So I FOILed out these first two. We got 12 minus 3i minus 16i plus 4i squared. Like terms in the middle. 4i squared is negative 4. And then I distributed the minus through the back two. Minus 9 plus I squared. Now, coming on down, we've got 12 minus 4. What's that? 8. Minus 19i. Ooh. What am I doing? I'm getting all messed up here. 12 minus 4 is 8. Minus 9 is minus 1, right? Is that right? Minus 1 minus 19i squared plus I squared. Everybody good to there? I just gathered the three numbers. The 12 minus 4 is 8, minus 9 is minus 1. Okay. And then what do we do with I squared? We can't leave I squared as I squared. That's negative 1, isn't it? That's negative 1. So this is going to be negative 1 minus 19i negative 1. So that's negative 2 minus 19i. Did you get that? That's a mess. Questions on all that? That's the kind of thing that I would often do over again later. I'd see that in class and go, that was a mess. I'm going to try that again later. Yeah, just see if you can do that. If you can foil the first two, I guess that's what you have the homework. You have the homework to try that. It'll give you a little bit different one on that. No questions? I good? All right. Okay, so try number 13. What do we do with negative in a root? Comes out as an I. Those negatives in the roots come out as I. Yeah, this should be an easy one. Funny how they change between hard ones and easy ones. Back and forth. So, the negative in the root comes out as I, and the negative in the root comes out as I. So negatives in a root do, they come out as I, and then the root of 16, as you know, is just 4, and the root of 4, as you know, is just 2. So this is 12i plus 14i. This is 26i. Done. How we doing? This good? All is good? All right. Let's try this one. We'll do this one, then we'll take our break. So they want you to plug that 2i in for x. So 2i, plug it in there for x, and in there for x. That's kind of a long one. So plug in 2i in both those places. And then simplify. There's going to be a lot of simplification there. The problem is, there's going to be parentheses around 2i. The 2i, the whole thing is squared. Yeah, like that. So what's that going to be? Yes, which is negative 4. Yeah, good. All right, so notice we're going to plug in here. So what we're going to get is 2I squared plus 8 over 4 minus 2I. Does everybody see what I did? I plugged in the 2I in the top and the bottom. Now that 2I is squared. You've got to put parentheses. See how I put parentheses around it? Why do you have to do that? Because you have to say, if you just write it this way, if you just write it like that, you're not really squaring the whole 2I. And they told you to square the whole x, and the x is 2I. This would mean only the I is squared, not the 2. That's wrong. Because they told me to square all of x, and all of x is 2I. All of 2, it's going to be 4I squared in the end, isn't it? Everybody see that? So that's why, whenever you plug into formulas, you have to plug in with parentheses around the thing you're plugging in. Otherwise, you might not be true to the meaning. And this would be one of those cases where it would not be true to the meaning. Does everybody see the difference between the parentheses and the non-parentheses? It's about whether the whole thing is squared or just the I is squared. Which one's right? Well, the whole x is squared. So the whole 2I is squared. You need the parentheses. So then what do you get there? 4I squared plus 8 over 4 minus 2I. Is that good? How are we doing? Are we having fun? Is this good? Kind of messy stuff, isn't it? And what's 4I squared? Negative 4. Isn't that negative 4? Because I squared is negative 1. We never leave I squared, right? That's negative 1. And so the top becomes negative 4 plus 8. Now what's negative 4 plus 8? 4. Are we good to there? Eight minus 4 in the top. So are we all good to here? Is this good so far? We can't stop here. Why not? Why can't I just stop here? Because I have i's, which are roots in the bottom. We can't leave roots in the bottom. We can't leave i's in the bottom. So you know what to do now, right? Look on your neighbor's paper. No. Check and see if we're all still here. Conjugate. Multiply by the opposite sign in the middle. 4 plus 2I over 4 plus 2I. See what you get from there. So that 4 is going to distribute. 16 plus 8I. On the bottom, it's going to FOIL. 16 plus 8I. Boom, boom. Minus 8I. Minus 4I squared. Good. These two cancel. We get 16 plus 8I over 16. What is minus 4I squared? Positive 4, huh? Remember I squared? We never leave I squared. It's a negative 1. Changes the sign of whatever it's next to. So that's really 20 on the bottom, isn't it? And you got to separate it. It's 20. And you got to separate it. And then you got to reduce those two fractions. A lot of steps on these. So then final answer will be, what's that, divide, what am I going to divide by? Divide by 4, top and bottom, be 4/5. Divide by 4 top and bottom, 2/5 I. There it is, 4/5 plus 2/5 I. And there's the fly. Good on that? All right, I think we need a break. All right, so bunch of fancy words. Let me just simplify it there. So it's going to say E equals IR. E equals IR. Okay, so they're giving me the formula. That's if you go take higher, do engineering, they'll have you do some of these circuit equations. E equals IR. And then they're telling me over here, change that up. I is 7 minus 3I, and R is, what is that? So I is 7 minus 3I, R is 2 plus 6I. 2 plus 6I. I'm going to take that and plug it in for I. Take that and plug it in for R. Does that make sense there? I'm plugging in I and R. So then I is 7 minus 3I. R is 2 plus 6I. And then we just multiply. We just FOIL those out. So I'm just going to go boom, boom. So what do I get? 14 plus 42I, boom, boom, minus 6I, minus 18I squared. Not good to there? And then we gather like terms. So what do we have? 14, these two in the middle. Is that 36I? And then what do you do with minus 18I squared? What becomes of minus 18I squared?
Plus 18.
Plus 18. Because I squared is negative 1. And then 14 and 18. What is that? 20, 32. Yeah. Plus 36I. Done. So it's just a real life problem with circuitry stuff.
You just remember the formula.
You don't have to memorize.
No,
Well, they give it to you.
right.
Yeah. So in the test, I would give it to
I
you.
was going to say, will they always
Yeah.
give it to?
Test will always be just like homework. So the homework's giving it to you, the test will give it to you too.
Okay.
Yeah. Does that make sense then? So just plug those in and do that. All right. So